Hey everybody, this is Larry. This is me going Q3 of the bi-weekly contest 57, Describe the Painting. So this one is a tricky, hit the like button, hit the subscribe button, join me on Discord, especially if you like doing contest problems, then, we can go over right after the contest together. So anyway, Describe the Painting is a tricky problem that I I use. I mean, this is a, as you can see from the graphs, it's a line segment problem, and and um, and with line segment problems, a common technique for me, or 1D line segment to be clear, um, it's going to be sweep line algorithm. And for sweep line algorithms, you just basically, it's a common paradigm, but you basically, you look at this graph as you see here on example one, and you basically imagine a vertical line that goes from left to right, right? And in terms of implementation, we'll go over in a second. But it turns out for this problem, one observation which I didn't make and took a little bit of time is that whenever there's an add remove event, you always create a new segment. The reason, even though you're able to merge some, the reason is because the set um, of colors will not be the same. Hmm. So yeah, I think there's a, yeah, because each color is distinct. Because each color is distinct, um, there's no way to kind of have the same set of colors every time you add or remove. Because every time you add or remove, um, maybe I misunderstood. No, yeah, because every time you add or remove, it's always going to be a unique um, set of colors because all the colors are distinct. So that means that you cannot add the same color twice, right? So having that in mind, it makes the problem a lot easier. I didn't notice this until later on, and you can watch me solve it live afterwards. But I didn't notice this until later on, so I was trying to figure out a way to keep track of things. And you can do it that way, but it's just a lot messier than the way that I end up doing. I did honestly also have a wrong answer anyway, but I'll explain that in a second. Uh, yeah, but there are a couple of ways to implement sweepline algorithm because the way that I describe it is way straightforward, but you may have trouble implementing it. And and yeah, the way that I did it today is just I keep track of all the events in a dictionary. I basically say, hey, at the start, add the color. At the end, remove the color. And in this case, as we said, we don't actually have to keep track of the color. We just have to keep track of the sum, right? So here, this is prefix sum pretty much. We take this colors and then we make it a prefix sum by adding all the previous or adding the previous element. And and yeah, and then here we just convert it back to an answer by looking at adjacent elements. And as long as the colors is not zero, because if it's zero, that means that there's no colors there. There are no colors there. And you just put it in the array. This is what cost me 5 minutes, is that I kind of rushed it a little bit and I forgot that, like for example, if you look at example 3, you added something between 9 and 10. My initial code would add like a, hey, there's a segment between 7 and 9 that has color 0, which is obviously not a good answer. So yeah, that's why I got a wrong answer on. After I fixed that, it looks okay. And that's pretty much it. In terms of complexity, the only thing that is super linear is this sorting here. And we sort all the keys of the segment and can't really do without it. So to be able to get it in order, you can do a sort of a linear quote unquote time solution by looking at the start and end and putting an array or something like that. But that's gonna, that's up to you to upsolve and think about the analysis in that case. But it's quote unquote linear, but you could consider linear if you like, but it makes some other parts of the code a little bit trickier. So yeah, uh, hmm, I think that's all I have. And oh yeah, it's linear space because we just use this the entire time. You could say we also create a list here, but that's also linear. And of course, the output array is going to be linear-ish in the worst case, though it's output sensitive. Yeah, that's all I have for this one. Um, Let me know what you think. I don't know if I'm going a little bit too fast on this one, but yeah, but I think the key observation is that at every the key observation is that the colors are distinct, so you create a new segment at every event. So yeah, and if you do struggle a little bit with this one, because I think I'm going a little bit fast because this is a very mm, very common-ish sweep line algorithm. So definitely practice other sweep line algorithms or line sweep algorithms or some yeah, and kind of yeah, just practice and you'll get there. Anyway, you could watch me sub it live during the contest next. Hopefully that's right. Okay. A little bit slow today, but I'm not quite where I usually am, so that's fine. This is like I have the same solution as last Q2, which is weird, but maybe I go the other way. Okay. 7-0, is that right? 7-0. Hmm. Oh, 7-0 because that's the last element. Okay, that's right. We're mostly done here. Oh wait, maybe not. Why is this different? Oh, that's why this is a little bit harder. Hmm. Okay, that's not that bad. Yeah, maybe I couldn't have done it this way, but this is the tricky one, I think. I should have done it the other way. Did I have it? 1 to 4? No. 4 to 7. No, I think I had it right actually. Oops. Maybe. Yeah, okay, maybe I did have it right. Maybe I didn't need that one. Okay, so like this. I think I'm off by 1, but maybe not. Yeah, let's give it a spin. Oof. Yikes. Oh, I have a 0. That makes sense. That is the end of the thing. I was thinking about that, but then I forgot. I wish I had a mouse on me, but okay. This looks good, so let's give it some minute again. Silly mistake. Yeah, thanks for watching. Hit the like button, hit the subscribe, and join me on Discord. Let me know what you think about this problem. Yeah, hope you do well, and stay good, stay cool. I will see you later. Bye bye.